Today we're going to look at factor by grouping. So I've listed out here for you 4 steps to follow. So if you get lost in the process, go back to these 4 steps and make sure that you're following them exactly. So we are going to start by looking at this polynomial. Now factor by grouping is used with just 4 terms, not 5 terms, not 3 terms. So we only use factor by grouping when we have 4 terms. And it doesn't always work with all types of polynomials that have 4 terms. But for your homework, they should all work out the way they're supposed to. So what we're going to do is always look for a GCF first. So just like we did with trinomials and just like we did with binomials, we want to look at the coefficients here, here, and here. And we're going to look at the GCF first. And as you can see, 12 and 18, which are our only numbers, they have a greatest common factor. Now 12 is your smallest. So your factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Well, 12 doesn't divide into 18. So the next largest factor of 12 is 6. And 6 does indeed divide into 18. So our greatest common factor for the numbers is going to be 6. And then you want to look at your variables. Do they all have an x in common? Yes. How many x's do they have in common? So you're asking yourself, how many x's can I take away from each term and take the same amount? And so since this one has the least amount to give, we can only take 1 x from every term. So our GCF is going to be 6x. So we'll deal with that in a minute. Then once you take out the greatest common factor, what you have left will still be 4 terms. That GCF will have to come out in front, and you leave it there. Then we're going to split the polynomial into 2 sets of 2 terms. So we're just going to cut it in half, and you'll factor the GCF from each set. And what's left in the parentheses should be the same. So we're going to go through this so it'll make sense. You might have to factor a negative from your second grouping of 2 in order to force the parentheses to match. And so you should see that happen in this particular problem that we're doing. So I am going to get a bigger frame. Here we go. And then you will factor out that common polynomial, and then you'll write your answer as the product of the 2 binomials. And if you have a GCF, you have to make sure that that stays in front. So I'm going to extend this page, and here we go. So our original problem was 12 x to the 4th minus 18x cubed minus 12x squared plus 18x. So as we stated before, our GCF is equal to 6x. So I'm going to divide each of these by that 6x. And then it is going to come out in front. And I'm going to use brackets because we're going to have a lot of stuff going on. And so 12 divided by 6 is 2. And remember your exponent rules. When dividing like bases, you're going to subtract exponents. And the exponent here is 1. So we've got 4 minus 1 is 3. So I end up with x to the 3rd minus 18 divided by 6 is 3. And then 3 minus 1 is 2. So that gives me an x squared minus 12 divided by 6 is 2. 2 minus 1 is 1. And then 18 divided by 6 is 3. And then these just cancel. So then the next step said to divide it into 2 groups of 2. So you've got to split it and keep the sign with the term. So when we split it here, notice that I kept the negative with the 2x. So then I'm going to factor out the GCF from this group and pull it out in front. Mind you, this is still going to be in front. So my 6x is going to be in front. So the GCF between 2 and 3, there isn't one. But notice how they both have x's. And the most amount of x's that you can take away from both of them and take the same amount is 2, because this is the smallest one, and that's the most that it can give. So our GCF for this first grouping of 2 is going to be x squared. So I'm going to factor out in x squared. Whoops, it's supposed to be blue. There we go. I'm going to pull that out in front of parentheses and divide each of these by an x squared. And so 2 divided by 1 is 2. 3, so we're using our exponent rules. 3 minus 2 is 1, so we're left with just an x. And then minus 3, and then the x squareds here cancel, and in parentheses. Now in the second grouping, you may not take out the same GCF as we took out here. But what's left in the parentheses over here should be a 2x minus 3. Now technically, negative 2 and 3 don't have a GCF, and they don't both have an x in common. So this is that situation where we had up here where I said you might have to factor out a negative from the second parentheses to force it to match. And so every term has a 1 or a negative 1 in common. So we want this 2x. Notice how this is negative 2x plus 3, and this is 2x minus 3. The signs here and here are opposite. So the way to fix that and force the parentheses to match would be to factor out a negative 1. So we are going to divide here by a negative 1, and you've got to factor a negative 1 out in front of those parentheses. So negative 2 divided by negative 1 forces it to be a positive 2 and then x. 3 divided by negative 1 forces it to be a negative 3. And so now you can see that what's in parentheses is the same. So what's going to happen is we're going to still keep this greatest common factor of 6x out in front. So pull that out in front. And then this is one term because they're all being multiplied. And this is a second term. The factors in this term are x squared and 2x minus 3. The factors in this term are negative 1 and 2x minus 3. Do you see that they both have a factor of 2x minus 3 in common? So we're going to take this factor right here, this 2x minus 3, and we're going to pull it out in front of parentheses. And then what's left over, the x squared, because we're taking the 2x minus 3 out of those terms, the x squared will go here, and the negative 1 will go here. And then we have all addition and subtraction signs inside of parentheses, and everything is fully factored. And so as you can see, this right here is fully factored. This is just a monomial. This actually can be factored, which you don't know how to factor yet unless you remember. And we'll talk about that later, but technically this is the difference of two squares, and it factors into a plus and a minus factor, but we're going to leave that for right now because we're going to talk about special cases in the next lesson. So let's try some of these on our own. So I'm going to go ahead and go through this left example with you first, and then let you do this second example here on your own. So following the rules, we're going to look for a GCF. So as you can see, we've got 1, 2, 3, and 6. Those numbers do not have a common divisor, therefore they have nothing in common. And they don't all have an x, and they don't all have a y, so there is no greatest common factor. So instead, we're going to cut these into two groups of 2, and we're going to look for the GCF in the first group and the GCF in the second group. And hopefully when we factor that out in front, what's left in the parentheses should be the same. So over here, the coefficient here is 1, and here is 2. So they don't have a number in common, and they don't both have an x, but they do both have a y. And the most y's that they have in common is just one y. So the GCF here is a y. And we're going to factor that y out in front of parentheses. And so what we have left over, the y's are going to cancel, so we have an x. The y's are going to cancel, and we have a plus 2. So hopefully in our next grouping, we'll have an x plus 2 as well. So here, the 3 and the 6 have a 3 in common, so we will factor out a 3, but they do not both have an x. So the only GCF that we have is a 3. We're going to divide by 3, and when you pull that 3 out in front, you need to include its sign as a plus 3. That's going to be important for our next step. So you see what's left in the grouping. The 3's divide, and I have an x, which is exactly what I'm looking for, so these match. And then 6 divided by 3 is a positive 2, and again, matches here. So notice again what we have in parentheses is the same. So y is a factor and x plus 2 is a factor of this whole term. 3 is a factor and x plus 2 is a factor of this whole term. So they have an x plus 2 in common. So we are going to factor this x plus 2 out in front of parentheses because technically we're dividing it out. And so we're taking it away. And so what's left over when we take away the x plus 2's is this y and plus 3. So that's going to go in the empty parentheses behind. You get y plus 3. Now, as you know, it doesn't matter what order your parentheses go. You can have y plus 3 times x plus 2. That's fine. So then I want you to pause the video and try this example on your own and see how you do. Make sure you look for a GCF overall for all 4 terms first. If you don't find one, then cut it in half and look for a GCF, and factor. So pause the video and try it. Okay, so hopefully you pause the video. There is no GCF for all 4 of these terms. So we're just going to cut the terms in half and look for a greatest common factor. So 4 and 2 have a 2 in common. So we're going to divide them by 2, and then they both have x's, and the most x's they have in common is an x squared because that's the most x's this term can give. So your greatest common factor for this first set is 2x squared, and you're going to pull that out in front and then see what's left over. So 4 divided by 2 is 2. 3x's minus 2x's gives us 1x. The 2's cancel and the x squares cancel. So remember, when everything cancels, it's not nothing. You don't just leave 2x. Anything divided by itself is 1, right? Because 2 divided by 2 would have been 1. So 2x squared divided by 2x squared is 1. So you have to put a plus 1 here. And as you can see, just like what happened in our example on the previous slide, this is almost the same, but we have a negative 2x instead of a positive, and a negative 1 instead of a positive 1. So the signs are opposite. There is no GCF, so we are going to factor out a negative 1 to force the inside parentheses to be the same. And when you factor that negative 1 out, it comes out as a negative 1 parentheses, and then all the signs are going to change. Negative 2 divided by negative 1 is a positive 2x. Negative 1 divided by negative 1 is a positive 1. And now you can see that what's in parentheses is the same. So we are going to factor out this out in front. 2x plus 1 times, and then this times this is going to go into parentheses here because that's what's left over when we take away a 2x plus 1 from each of those terms. And then this is fully factored, and this binomial is fully factored. So you are done. So congratulate yourself if you got that correct. Good job. If not, go back and review the steps again, and let's look at our last slide. So in this particular slide, we're going to once again, I'm going to do this with you, and you do this one on your own. We're going to look for that greatest common factor. And so 9, 36, 4, and 16. Well, 9 and 36 has something in common, and we could divide them both by 9, but I can't divide 4 by 9. So remember, go to that smallest number, 4. 4 divides into 16, 36, but not 9. So there is no GCF for numbers, and they do not all have an x. So once again, no GCF. So we're going to start off by dividing that into 2 equal pieces. 100% of the time when this third term here is negative, you're going to factor out at least a negative in your GCF. So here we go. Let's look at this group, 9 and 36. 9 is the smallest. 9 does divide into 36, so 9's our GCF. They both have x's, and the most x's they have is an x squared. So we are going to factor out a 9x squared out in front of parentheses. And so the 9's are going to cancel. And then 3 x's minus 2 of them gives us a single x. And then 36 divided by 9 is 4. and the x squareds cancel. So then over here, not only do we have to factor out a negative, but notice that the 4, which is smaller, divides into the 16. They do not both have an x, so the greatest common factor that we are going to factor out is going to be a negative 4. If you don't factor out that negative, the signs are not going to match in the parentheses. So anytime that third term is negative, make sure you factor out a negative. And so let's perform our division. So the negative 4s are going to cancel. It's supposed to be blue. And so you're left with a single positive x, which is what we wanted. Then negative 16 divided by negative 4 is a positive 4, which is what we wanted. So now this matches in the parentheses. So we're going to factor out in x plus 4. And then in the next parentheses, we're going to put the 9x squared minus 4. So I'm just going to chat with you a little bit about the difference of two squares, because you should remember that from Algebra 1. So let's look at, we're going to just bring down the x plus 4, because this is not the difference of two squares. Remember, you can factor that difference of two squares into a plus-minus pattern. And we will talk more about this in the next lesson, but you're going to come up against this with factor by grouping. So notice that this is a perfect square 9 and a perfect square x squared. Anytime this exponent is even, it's a perfect square. And then this is a perfect square. So the square root of 9 is 3, the square root of x squared is x, square root of 4 is 4. So the difference of two squares factor pattern looks like this. So if you have a perfect square minus a perfect square, 100% of the time it's going to factor into a plus b and a minus b. Where do I get the a and b from? Take the square root of this first term. Square root of a squared is a. So that's going to go in the first slot. And take the square root of the second term. Square root of b squared is b, and that goes in the second slot. And then you just have a plus and a minus. And that's it. So here, the square root of 9 is 3. And the square root of x squared is x. So a 3x is going to go in both slots. Then for the last slot, the square root of 4 is 2. So we're going to put a 2 here. And then that's it. So we're going to go back, all the way back to the first slide. And we are going to factor out that difference of two squares that I told you about. So let's go back to the first slide. Down here. Let's see. So all the way down here, remember I said that this was a difference of two squares? Well, x squared is a perfect square because this is even, and 1 is a perfect square because what's the square root of 1? 1. So this can actually be factored further. So let's go ahead and rewrite the parts we're not going to touch, the 6x bracket, and then the 2x minus 3. Whoops, yeah, that's what I want. But then the x squared minus 1 factors into two binomials with a plus-minus pattern. All right, so remember, to get this, since this is the difference of two perfect squares, we can take the square root of these numbers and put them in the first slot and the last slot. So the square root of x squared is x. So an x goes here and an x goes here. The square root of 1 is 1. So we put a 1 here and a 1 there. And now this is fully factored. And now we're considered done, which is why I didn't box it in the first place. All right, so let's look at the last problem, and I want you to try this one on your own. It definitely has a greatest common factor overall, so it's very similar to the first one that we started with. So you go ahead and pause the video, make sure you factor out the GCF, cut it in two, factor out the GCF from each of those terms, pull those out in front, make sure that the inside parentheses match, then factor that out. And then if you have the difference of two squares left in one of your parentheses, factor that as the difference of two squares. So pause the video and give it a try. Okay, so hopefully you determined that the smallest number out of these is 2. And 2 divides into 24, 6, 8, and 2. They do not all have an x in common. So there's no x for the GCF. But we are going to factor out the 2, and remember, it doesn't disappear. It comes all the way out in front, and I'm going to use brackets. and then we're going to divide. So 24 divided by 2 is 12, x cubed. Negative 6 divided by 2 is negative 3, x squared. 8 divided by 2 is 4x. And then remember, anything divided by itself is 1. So that minus 2 divided by 2 does not disappear. It becomes a minus 1. So then we're going to cut the inside here in black into 2 pieces. And look at the first grouping. We've got a 12 and a 3. So this 3 divides into 12, so that's our GCF. And they both have x's. This is the smallest amount, so the most that these two can give is an x squared. So our GCF is going to be 3x squared, just for this group. So then I'm going to bring this 2 out in front, and then the 3x squared is going to come out in front of parentheses. And so I've got 12 divided by 3 is 4. And then 3x's minus 2x's is 1x. And then the 3's here cancel and the x squareds cancel. So again, anything divided by itself is 1, so we have a minus 1. Notice that here the 4x matches the 4x and the minus 1 matches the minus 1. And there is no GCF. So how do you deal with that situation? So that's possibly where you got stuck. So in this case, remember, I can divide anything by 1. So technically, we are going to be factoring out a 1 from each of these. And we're going to put a plus 1, because that's its sign, out in front of parentheses. So anything divided by 1 is itself. So we have 4x minus 1. And the reason why that was important was because I've got to know what's in front of this parentheses right here. So we've got these in common, so that we're going to pull that out in front here, so we're still going to maintain the 2 in front. So I've got 2 bracket. Then because we've got this 4x minus 1 in common, that's going to be pulled out in front of parentheses. And then what's left over, when I take away a 4x minus 1, I'm going to have a 3x squared. Take this away, and I'm going to have a plus 1. So 3x squared plus 1. And then look at your parentheses and make sure it's fully factored. Although 4 is a perfect square and 1 is a perfect square, this is not an x squared. So this does not factor as the difference of 2 squares. This is done, fully factored. And then this is not the difference of 2 squares. So we are 100% factored. All right, well, good luck on your homework, and remember to text me with questions.